Breaking the Wall of Artificial General Intelligence. How AI will reshape the frontiers of science and human potential. Richard Socher, U.com.
On November 9th, 1989, I was 6 years old in Dresden. I can't remember much from that day, but I have a piece of the wall my dad brought back. It reminds me how a barrier's fall can open up a world of possibilities, something I strive to achieve through my work in AI.
Hello, everyone. I'm really excited to be here. And I want to talk to you today about not just AI, but AGI. Why AGI? Because it might already be here in some form. So what is it, and why do we even talk about the difference now between AI and AGI? Well, AI started with just looking at what humans can do and trying to build one model that can accomplish a task that humans can also do. For instance, like machine translation. We can now have an AI model that can translate between all the different kinds of languages. And in many ways, it's already superhuman in that way. There's not many humans that could actually translate 100 different languages, right? But where we are now is actually that we're able to have a single model that can be broadly applied to almost any task in natural language processing. And because of that generality, it's actually almost fair to say that on various types of modalities like natural language, we already have artificial general intelligence, general capabilities across every single task in natural language processing. What's even more exciting is that instead of just creating texts, you can think of these models as neural sequence models. They're just trying to predict some kind of next token, and that next token could be an English word, but it can also be a click, an action on an interface. And what that means is that basically all work as we know it is going to change in the next few years. Every single task where you take as input some kind of knowledge, be it in computer vision, like visual inputs or textual inputs, and you need to produce an output that includes clicking on an interface on the web or in some software, or producing then some email or some other text, all of those kinds of jobs are going to change in the next few years. Now, of course, future is already here. It's just not equally distributed, right? There are some places, unfortunately, in Brandenburg that still don't have proper internet. So this won't happen overnight, as some people claim, but it will come much, much faster than previous industrial revolutions. And in fact, there's a really interesting paradox from one of the previous industrial revolutions, named the Jevons paradox, that I'm rephrasing here in the age of AI. What Jevons realized during the first industrial revolution was that there's an odd situation going on. Namely, at the time, a lot of the really smart engineers were working on making steam engines more efficient, to use less coal. And they all expected that as they're making those steam engines more and more efficient, we could use less and less coal. But really what happened is people just realized all the different places you can use engines to do stuff. And so they actually ended up using more and more coal, even though the engines became more and more efficient. And that is exactly what I think is going to happen on the planet right now in the era of AI. We will see intelligence be used in more and more different parts of our lives. And we'll have things that currently we couldn't afford because intelligence on some level is still too expensive. But the marginal cost of generally using intelligence is going down and will continue to go down as hardware gets cheaper, data access gets better, these models get better, and we understand how AI works better and better. Now, this didn't happen overnight. I've been working and actually been very fortunate that in 2003, even, at Leipzig University, there was a field of study called linguistische Informatik, linguistic computer science. And so for over 2 decades now, I've been very excited about AI and natural language processing, and been training neural networks for quite some time. And a lot of times in Silicon Valley, we now talk about the BC era, not before Christ, but before ChatGPT. But this didn't happen overnight. There's actually been a lot of foundational researchers, and many of us have just been excited because we believe that intelligence is one of the most, and probably the single most differentiating factor to every other type of animal. And if we can create something, if we can build something, then we understand that something better. And I'd argue that we're understanding the very nature of intelligence and what makes us human better as we're able to recreate it in machines. Now, I mentioned this, and I want to just bring that up one more time. Every single company that we know of that uses knowledge and knowledge workers is going to face some kind of innovator's dilemma, like Clayton Christensen defined in his famous book, where the way we used to make revenue is going to be very, very different in the future. Now, a lot of people ask me, well, how can I predict that future? And I'd actually argue that at least for the next 5 to 10 years, we can often look at what very wealthy people have access to in terms of products and services. And you can think about this, if you're very wealthy, you probably have a personal assistant, right? You're a CEO, you tell like, oh, I need to fly this way and that way and over there. You'll have an assistant that will book those flights for you, get the hotel, and organize everything. We can all have a personal assistant in the future. When technology comes into the field and you realize the possibilities of scale, we end up in a place where a billionaire and a middle-class teenager end up having the same iPhone, right? But they currently do not have the same personal assistants or the same personalized tutors for their children or a personalized healthcare team that knows exactly what their DNA is, that has done all the right and maybe more novel imaging, as we've just seen, and has been following you around for years and years to be able to help you get into a much longer health span and lifespan. We're seeing this also in the workplace, and this is something that I personally work on a lot. And just to give you a sense of how powerful these new algorithms are, here's a random question that I had during an argument with my parents about over or underpopulation of the planet. I actually believe that the planet, if we set it up well and have the right political structure, we could easily have space for sustainably having 30 billion plus people. And so they're like, no way, that's not possible. I always hear we're too many people and whatnot. And so I asked, like, how many Germanys could fit into the Earth's landmass? Because I used to live in Montana for a year, and Montana has maybe the population of Frankfurt, right? But it's roughly the size of Germany. And so when you ask this kind of question to an AI assistant, it will basically realize that in order to answer it, it has to go through all of these different steps, find citations for every one of those potential facts, visualize all of that for you, do all the math, looking at the size of Germany, then looking at how much habitable land there is, find regions of similar climate, because that was, of course, it's not helpful if it's in Greenland or Antarctica, and then provide you citations for all of those steps, and then even program for you in order to do the right math. Because a lot of times in the early days, large language models were terrible when it came to mathematical and logical reasoning. But one way to fix that is actually to allow them to program. And then after programming, they can do now also mathematical and logical reasoning. And then they'll answer even such complicated questions right away. And that is as big of a difference as the early days of Google were. But now the problem isn't anymore access to information, it's trying to deal with it and reason over it and summarize all of it for you, and that's exactly what AI can do for us now. Now, it's not quite easy. There are a lot of different companies and startups and universities that are working on this, and it is pretty incredible how quickly you can put together a demo of this technology, right? We can all go on ChatGPT and try something out, and it kind of works, but then it's just kind of, right? It's like 70% accurate, and it turns out it takes another year or two to actually get it to an accuracy that you can then rely on it for your work, but that is where we are now. And I'm really excited actually to have a variety of organizations now that are using U.com, my company's line of work, and one as a nerd here that I'm most excited about is actually just last week we got the Institute of Advanced Study that also really cares about, in Princeton, that also really cares about accuracy, becoming a customer of U.com. Now, we talk a lot about large neural sequence models, agents, large language models like ChatGPT, but one thing that we have to kind of understand is that all of these models are essentially just very large neural networks that try to predict some kind of next token. And they don't really care about whether that token is a piece of English language, or it's a protein, or it's a programming language like Python. They'll just read a bunch of text and then try to predict that next token. And just to give you a sense why that's so incredible and how much intelligence is required to predict the next word, you can think of things like geography, right? If I am saying, I'm in Berlin and I'm driving south too, and I'm trying to predict the next word now, I need to know all of geography, right? And if you read a large crime novel and you get all these little clues, and after 100 or 200 pages, it says the murderer is, now you need to do so much reasoning just to predict that next word, right? And that simple idea has led to all of these incredible advances that we're seeing. And in 2018, I had this idea of saying, okay, everyone gets it now for natural language. How about we use it on the language of biology, namely proteins? So you just have a bunch of sequences of amino acids, and you try to predict the next one. And it turns out that worked. We're actually able to synthesize those proteins in wet labs, and they folded, and they had antibacterial properties the way we wanted, and they were 40% different to any naturally occurring protein. Just to put that into perspective, Francis Arnold won the Nobel Prize a few years ago for also creating novel proteins that were 3% different to any naturally occurring protein. AI has understood in some fuzzy way, we don't even understand exactly how it does it, but it has been able to now create new kinds of proteins that actually have the functions that we want them to have. A lot of different companies are working on that, but I often say, software is faster than hardware, novel, innovations and so on, and hardware is faster than wetware. So all of this stuff in biology takes a lot longer to get out, but I very firmly believe that we'll have several ChatGPT-like moments for medicine because of this line of work. And I want to end on two thoughts. One is very specific, a project that got me extremely excited about the potential of AI and protein engineering for medicine, and then just a very high level of thought to end. This paper, when I saw and read this paper just randomly a few months ago, I got almost giddy with excitement about the field. So this professor in Toronto built these tiny carbon nanotubes. So just tiny molecules, bunch of carbon around in their tubes. And inside, he stuck iron molecules. And on the outside, he coated these carbon nanotubes with proteins that would only bind to brain cancer cells. So carbon nanotubes, iron molecules inside, proteins coating that only bind to brain cancer cells. Then he injected all of these carbon nanotubes into mouse with brain cancer. And then he put the mouse into a small magnetic field. And with that magnetic field, and thanks to the iron molecules inside, he could now spin around the carbon nanotubes at each cell. And he has essentially built a molecular-size scalpel for just brain cancer cells. And if you can then realize that proteins will be able to get generated. Wait, I still have a minute, no? The robot was broken. All right. Minute and 2 seconds now. If you now believe that, no? Wait, do I have 50 seconds or no? Can't speak? Okay. All right, we'll wrap it up. So, if you now realize that we can create proteins the way we can create a sonnet in ChatGPT, you'll just be very excited about the potential that AI will have in biomedicine. We're basically now entering the age of AI, which is a new era that won't repeat exactly, thank you, 22 seconds. That won't repeat exactly history, but it will rhyme with the eras of the Renaissance, Enlightenment, and the Industrial Revolution. And with that, I'm really excited to see an event like the Falling Walls Summit, where we can all try to go back out into Germany and the rest of Europe and help improve the marketing that the future desperately needs. Thank you.